Assalamu alaikum, dear students. Today we have another topic that is 3.9 collisions. So we are studying those topic which is according to our smart syllabus. Okay. So first I am going to define the collision, the term collision. What is meant by collision? In Urdu it is called takraw. Okay. How we can define it? When two bodies come closer so that they can interact is called collision. When two bodies come closer so that they can interact, that is called collision. Suppose if mass m1 is moving towards right and mass m2 moving towards left, they will come closer to one another and they will collide. So when they collide, maybe this mass is moving towards bounce back, this mass will be bounce back, so their velocities, momentums and kinetic energies will be changing. So that is called collision. So when two bodies come closer so that they can interact with each other, so that is called the collision. Okay, there are two types of collision. One is the elastic collision and another is inelastic collision. So there are two type of collision: elastic collision and inelastic collision. Elastic collision is also known as microscopic collision. Microscopic collision means it occur in small objects. That is why this is called microscopic collision, and this is called macroscopic collision because it is happening in the big objects, in the larger objects. So that is called inelastic collision or macroscopic collision. Okay. Now, first we are going to study the elastic collision. So we are defining the elastic collision as okay. The elastic collision is the first type of collision. It is defined as the collision in which total energy, linear momentum and kinetic energy are conserved is called elastic collision. When the total energy, linear momentum and kinetic energy are conserved, that is called the elastic collision. So look at here, the total energy, the linear momentum and kinetic energy, all these three are conserved. Conserved mean constant. So this type of collision is called the elastic collision. Okay, this is the elastic collision actually. So suppose we have a container in which there are gas molecules, okay. These molecules are in random motion. We know that the molecule of the gas are in always random motion, so they will collide with one another and with the walls of the container. So the molecule will collide with one another and with the walls of the container. So let us consider the two molecules come closer so that they come closer and they come in the physical contact with one another. When they come in contact physically, so they will bounce back in the opposite direction. So it means that this collision is elastic collision. Why? Because Initially, the total energy and finally the total energy is conserved. Initially, the total momentum and finally the total momentum is conserved. Initially, the kinetic energy and finally the kinetic energy is conserved. So this collision is actually called the elastic collision. So nothing is lost during the collision. Neither total energy, momentum, nor kinetic energy is lost. So it means that this collision is an elastic collision. And remember, perfectly elastic collision is ideal. Some sort of kinetic energy being lost in every real type of collision. So that is why we can say that in actual practice, elastic collision is ideal. So now another thing is inelastic collision. The collision in which the total energy and linear momentum are conserved, but kinetic energy is not conserved, is called inelastic collision. That is called the inelastic collision. Okay. When the total energy, linear momentum are conserved, but kinetic energy is not conserved. So this collision is called the inelastic collision. Okay. Suppose a car, there are two cars which are moving opposite to one another. So if we talk about their initial momentum, so they are opposite in direction. So their momentum will be cancelled with one another because momentum is a vector quantity. And when vector quantities are opposite in direction, so they will cancel each other effect. So its initial momentum is zero. So its initial momentum is zero. Okay, suppose the initial total energy is 100 joule. Okay, now when the initial kinetic energy is suppose it is also 100 joule, suppose let us consider it 100 joule. Okay. So because there is no potential energy, both the cars are moving on the road, and on the road the potential energy of the cars is zero. So it means the total energy is 100 joule is because of kinetic energy only. There is no potential energy. Okay, so look, both the cars are coming towards one another, so they are moving opposite to one another. So the initial momentum is zero. Initial momentum means momentum before the collision. Okay, now when they comes and collide with one another, so that is the final momentum, the final kinetic energy, the final total energy. Okay, when they come and collide with one another, they will come to rest. If they come to rest, the final momentum will also be zero. And if they collide with one another, they will be at rest. So their final kinetic energy is also zero, but the total energy will be of 100 joule, because when they collide with one another, the total energy is changing from one form into another form. Means the total energy will change from the kinetic energy to the sound energy to the heat energy to the deformation energy. Because look at here, look at my hand, they are colliding, so it's producing sound. So it means that energy will be changed from one form to another form. So it means the total energy will be remains conserved. But look at the kinetic energy. The kinetic energy is lost. So momentum initial was zero. The final is also zero. Initial total is 100. Final total is 100. So momentum is conserved. Total energy is conserved. But kinetic energy is not conserved. Because initial kinetic was 100. The final kinetic is zero. So this type of collision is called inelastic collision. Okay. This is actually inelastic collision. So here the kinetic energy is being lost in this collision, so we are not interested in inelastic collision. So we will study only elastic collision. Okay. First, First look why we are interested in elastic collision. So you should know the answer why we are interested in elastic collision, because in elastic collision everything is conserved. The total energy, the momentum, and the kinetic energy, each and every terms are conserved. So that is why we are interested in elastic collision. Okay. In our course, we will study one dimensional elastic collision, not two dimensional, one dimensional elastic collision. That is called the head-on collision. That is called the head-on collision. Okay. So we are studying an one-dimensional elastic collision. That is called the head-on collision. Head-on collision mean the one-dimensional collision. Head-on collision mean the linear collision. Okay. Suppose we have two masses. Mass m1 moving velocity u1, mass m2 moving velocity u2 in the same direction. Okay, this is the road. Let us consider that u1 is greater than u2. Okay, when u1 is greater means the velocity of m1 is greater, so this mass will approach this mass and will collide with this mass. So when they come in contact after a certain time, after a certain distance, then m1 pushes the m2 forward. So it means m1 applies the action on the m2 to move forward, and m2 pushes the m1 backward. It means m1 as a reaction, m2 will apply force on m1 to get slower, while m1 pushes the m2 to get faster. So it means that after the collision, the velocity of m1 will be smaller and the velocity of m2 will be greater, because m1 pushes the m2 forward to get faster. So it means that after the collision, the velocity of m2 will be greater. So that is why our common sense says that collision is possible if u1 is greater than u2 before the collision, but after the collision v2 will be greater than v1. So we have to prove this common sense by our calculations. Okay, now I am applying law of conservation of momentum. Initially both are in same direction, so their momentum will be added. Finally they are same in direction, so their momentum will be added. Okay, so what is the momentum of this mass? Look, what is the momentum? So its momentum is m1 u1. What is its momentum? Its momentum is m2 u2 is equal to, what is its momentum? Its momentum is m1 v1 and its momentum is m2 v2. u1 u2 are the velocities before the collision, v1 v2 are the velocities after the collisions. Okay, so this is the momentum before the collision, this is the momentum after the collision. So this is called law of conservation of momentum. Okay, now shift m1 terms on one side and m2 terms on the other side. So here we have an m1 term, so shift it on the left side. Here we have an m2 terms, so shift it on the right hand side. So we will have, look, m1 u1 minus m2 minus m1 v1, sorry, m1 v1, okay, m2 v2 minus m2 u2. Okay, first yes, it is correct. Now I shifted m1 terms on the one side and m2 terms on the other side. So taking m1 as a common, so m1 is common here, so it will be u1 minus v1, and here m2 is taken as common, so it is v2 minus u2. That is labeled as equation number 1. Okay, That is equation number 1. Now I'm going to apply law of conservation of kinetic energy. So apply law of conservation of kinetic energy. Okay. So look, the kinetic energy of this mass will be half m1u1 square, and the kinetic energy of this mass is half m2u2 square, and the kinetic energy of this mass will be half m1v1 square. The kinetic energy of this mass will be half m2v2 square. Okay. Look at on this page, the kinetic energy of the first mass is half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. Okay, these are the kinetic energy. This is called law of conservation of kinetic energy, means the initial kinetic energy will be equal to the final kinetic energy. Okay, now again the same process we will apply the same terminologies. Shift m1 terms on the one side and m2 terms on the other side. Okay, shift this m1 terms on the left side, so it will be half m1 u1 square minus half m1 v1 square. Okay, now shift this m2 term on the other side, so it will be m2 v2 square minus half m2 u2 square. Okay, now take half m1 as a common from the left hand side and from the right hand side. So half m1 is common, is taken as common, so it is u1 square minus v1 square, and here half m2 is taken as common, so it is v2 square minus u2 square. Okay, now half and half will be cancelled. So, and this is a formula, a square minus b square is equal to a plus b into a minus b. So use that formula, which is equal to m1 a plus b into a minus b, and here use a square minus b square formula, so it is equal to a plus b into a minus b. Okay, so we use this formula. This label is equation number 2. Okay, this is equation number 2. Now divide equation number 2 by equation number 1, so we will get, this is, I'm writing equation number 2. Okay, this is equation number 2. I am dividing equation 2 by equation 1. Divide by equation number 1. What is equation number 1? m1 u1 minus v1, and equation number 1 is m2 v2 minus u2. Okay, m1 and m1 will be cancelled here, u1 minus u1 cancelled, v2 minus u2 cancelled, m2 cancelled. So what we have, we will get u1 plus v1 is equal to v2 plus u2. Okay, we get this equation. Now look at here, shift u1 terms on one side, v2 terms on the other side. So here there is a u term, so this u should shift on the left hand side and v shift on the other side, so it will be u1 minus u2 is equal to v2 minus v1. Okay, now look at here, u1 is positive mean maximum, and u2 is negative mean minimum. And look at here, v2 is positive mean maximum, and v2 is negative mean minimum. So it is proved what we have studied in the starting of this lecture, that before the collision u1 is greater and u2 is smaller, but after the collision v2 is greater, v1 is smaller. So we prove that common sense mathematically. So that was our topic. Now we want to prove the velocities after the collision. That the velocities after the collision of mass m1 and mass m2. Okay. So look, this equation is labeled as equation number 3. So first we have to find equation. This is actually okay. So this is labeled as equation number 3. So let take the value of v1 from this equation and putting in equation number 2. So what we get? So